Okay, let's now talk about message passing, the IPC, inter-process communication, message passing. Okay, processes can communicate with each other without having a shared variable or memory. Okay, which one is better? This is, it depends on the situation, and message passing is really scalable, right? It is scalable. Having a variable is, shared variable is easier, could be. We will talk about this when the time comes. But anyhow, when you want to communicate through message passing, we have two operations. Makes sense. One of them is send, and the other one is receive. So you send a message and receive a message. Okay? This message could be fixed, so you have, let's say, 512 bytes of a message. Okay? Or it could be really variable. Okay? Now, if you have two processes, P and Q, so process number one, process number two, okay, that they want to communicate, okay, that's what they need. The first one, establish a communication link among P and Q. Communication link. This communication link, by the way, as you will see later, could be direct or indirect. We'll see about that. And it's used to exchange messages via send and receive. So as soon as you have here the P and you have the Q, you create, the tunnel, the communication link among them. Then this could send and this could receive, okay? So now, how would we implement this? So how are the links established? Can a link be associated with more than two processes? That's a question, okay, that we will see the answer later. How many links can there be between every pair? Can we have more than one links? Maybe. What is the capacity of a link? Those are all, design questions, right? The size of a message that the link can accommodate, fixed or variable, that's also something, And is the link unidirectional or bidirectional? So if you create the connection from A to B, is it only from A to B? Can it be also from B to A or not? So if it's only from A to B, that we call it unidirectional. If you can go both ways, it's called bidirectional. Okay. How would you implement it really physically? We can do shared memory, and you would see the code shortly. We can have hardware bus. We can have network. That's physically speaking. Logically, it could be direct. It could be indirect. So direct or indirect. Synchronous or asynchronous. Automatic or explicit buffering. Synchronous and asynchronous means the sender and receiver have to be synchronized. Asynchronous, they don't need really to be synchronized. Direct and indirect, I will be talking about them now. For direct communication, the processes must name each other explicitly. So send P certain message. So you want to send a message to process P. So the destination is P. So this is the destination, okay? Receive Q and message. Okay, receive a message from process Q. So Q is the sender. Okay, so Q here is the source, P here is the destination. So send destination message, receive source message. Do you see? What are the properties of the communication link? Links are established automatically. Okay, so that's number one. A link is associated with exactly one pair of communicating processes. So you cannot have more than one pair sharing the link. Between each pair, there exists exactly one link. So you cannot have P and Q sharing more than one link. It's not going to happen. Okay? The link may be unidirectional, okay, but is usually bidirectional. So the default, the usual is bidirectional, but it could also be unidirectional for this case. Which is means that, now you're going to be P and Q established the link. Now P is sending. The next moment it could be receiving, you see, which is really, really great. So this is what we call direct communication. Okay, we're going to be talking about the direct now when it comes to the blocking and unblocking and so on. Indirect communication. Messages are directed and received from mailboxes. The key word of the indirect communication here. Mailboxes. Okay? Also, of course, referred as ports. Each mailbox has a unique ID. Processes can communicate only if they share a mailbox. So for P and Q to communicate, they have to have a shared mailbox between them. The properties. Link established only if processes share a common mailbox. So if the processes don't have a shared mailbox, it's not going to be established. A link may be associated with many processes. The direct didn't work this way, right? It has to be a pair. Each pair of processes may share several communication links. And the link may be unidirectional or bidirectional. So the major difference here is, see, the mailbox, the association of many processes, and sharing, several communication links. You can always see the direct communication. If you studied networks, you can see it as a circuit switch. See? A circuit switch model where the path is defined from the sender to the receiver and so on. Okay? Where the packet switch is different. So you can always see the direct and indirect as a circuit switch and packet switch. Okay. Now, for the indirect communication, how does it work? You need to create a mailbox port. Then send and receive messages through the mailbox. You're done communication, then delete mailbox. Okay? If you work with TCP/IP, you will find that this is, defining the socket and then removing the socket when you're done and so on. This is a very common practice. And then you also send and receive. Those are the primitives. But here you send to a mailbox. Remember, the direct you send to the process itself. And here you receive from a mailbox. In the direct communication, you receive from the process itself. Okay, so those are mailboxes. For the indirect communication, P1, P2, and P3 can share mailbox A. See, more than two, eh? And here, P1 sends, P2 and P3 receive. Really? Yes. Both of them will receive because they're sharing the same mailbox, right? And that's what we call broadcasting. Who gets the message? That's a question, right? It could be the first one that picks it up. It could be, the message that has a flag of the receiver. Okay, many solutions here. See, allow a link to be associated with at most two processes. So you're going to be imitating here the direct communication, or allow only one process at a time to execute a receive. Okay. Those two solutions, this solution did not really guarantee that the desired destination is the one that's going to be picking it up, right? Allow the system to select arbitrary, which is not really accepted, the receiver. Okay, sender is notified who received it. The better way to do it is, the first one, of course, here. This is the one. To allow a link to be associated with at most two processes. Okay.